going to learn section 7.6 today, which is all about motion problems. And in order for us to do motion problems, we had to remember the basic formula, R times T equals D, where R stands for rate, T stands for time, and D stands for distance. So we had to remember that R times T is equal to distance. So we are going to use things called subscripted variables, and we're going to use those to help us keep straight the different types of variables that we're going to use. For example, if we're talking about two cars, a faster car and a slower car, we're going to use subscripts. We're going to have the rate of the faster car and the rate of the smaller car. And our example says the faster car is traveling 2 miles faster than the slower car. So together, they went a total of 612 miles. So the faster car, he's going, the time for both of them is 6 hours, right? And their distance is obtained by multiplying R and T. So R, which is R sub F, times 6 is 6 R sub F. So this 6 hours, I know it doesn't say in this little sentence right here, but that's given. That's something that you will be given in the problem, 6 hours, okay? So for the slower car, R, which has the rate R sub S, times 6, so the distance for the slower car would be 6 times R sub S, okay? So we know that the rate of the faster car is 2 miles faster than the slower car. So the rate of F, R sub F, is equal to whatever your R sub S is plus 2. And that's how we get this equation here. We also know that together they went a total of 612 miles. So these two numbers here have to add up to 612. So 6RF plus 6RS have to equal 612. So we have two equations here. And notice how this variable, RF, is defined using RS. So because of that, we're going to substitute this equation, or R of F, into that second equation. So it's going to look like this. 6, but instead of saying RF, I'm going to say RS plus 2 because that's what RF is equal to. And then plus 6RS equals 612. So now I just need to solve for R of S. So I distribute 6 times RS is 6RS. 6 times 2 is 12. Then I have the plus 6RS equals 612. Combine like terms, so I have 12RS plus 12 is equal to 612. And so I can go ahead and subtract 12 from both sides. So it should say 12RS equals, it should say equals 600 right here because 612 minus 12 would be 600. And then 600 divided by 12 would be 50. So R of S is 50. Well, now that I know that R of S is 50, I can figure out R of F because R of F is just 2 more than R of S. So to get R of F, I do 50 plus 2, giving me 52. So now I have both my rates. I have the rate of the faster car is 52, and then the rate of the slower car is 50. So again, summing it up, the slower car is traveling at 50 miles an hour, and the faster car is traveling at 52 miles an hour. Let's talk about wind and water. So in the water, or even in the sky, we have things called currents, right? And we fight against them. In the sky, airplanes come up against something called a headwind. So the headwind, it's either going to reduce the rate of speed or it's going to increase the rate of speed. So a headwind is going to reduce the rate of speed by x. So you're going to subtract x. But a tailwind, so wind coming up from the tail, is going to make the plane go faster. So it's going to increase the rate of speed by x, or it's going to plus x. And for water, a current of X miles an hour increases when you're going downstream, so you're going with the current. However, if you're going upstream, the current is going to decrease the rate of speed by X. So looking at an example, we're going to be in the water, okay? So downstream, we're going to have our rate plus our current. That's how we get our downstream, is a regular rate of water plus whatever the current is. Because when you're going downstream, you're going with the current, so you're going to go faster. So you're going to add the current speed. And then if you're going upstream, you're fighting the current, so your rate's going to go slower, so you're going to subtract the current. So for this problem, they're telling us when we were going downstream, we're going 3 hours downstream. And then we're going to go 2 hours upstream. And our distance when we went downstream was 12 miles. And our distance when we went upstream was 4 miles. So we want to know what was the rate of the water without any current, and then what is the current. So we have two equations. The first equation we have is 3 times b plus c equals 12, because we know that rate times time equals distance. Likewise, we have 2 times b minus c is equal to 4, because again, rate times time equals distance. So I'm going to take that first equation and I am going to solve for b. So the first thing I'm going to do is I'm going to distribute the 3. So now I have 3b plus 3c equals 12. Now I'm going to subtract 3c from both sides. So I've got 3b equals negative 3c plus 12. Then I'm going to divide everything by 3. So I get b is equal to negative c plus 4. So now that I've solved for b, I'm going to take that b and I'm going to substitute it into the second equation. So I have 2 times, but instead of saying b, I'm going to write minus c plus 4. And then I have my minus c equals 4. So I distribute 2 times negative c, or actually negative 2c is negative 4c. And then 2 times 4 is plus 8 equals 4. So I'm going to solve for c. I'm going to subtract 8 from both sides, and I get negative 4c is equal to negative 4, which means c is equal to 1. And now I know what c is. I can plug it back into this b equals negative c plus 4 to figure out what b is. So b would be negative 1, because it's negative c, and c was 1, so negative 1 plus 4. So b is 3. So what does that? That tells us the rate is 3 miles an hour, and the current is 1 mile an hour. So the rate without any current is 3 miles an hour, and the current is 1 mile an hour. So we do have this something called a knot, and a knot is just a unit of speed referring to nautical miles per hour, and it's approximately 1.151 miles an hour. It's often used to measure speeds in aviation and also like if you're on a boat. So you might hear it's 45 knots. So it's a unit of speed that they use. So let's look at an example. We have a flight to California and we have a flight home. So the flight to California, we're coming up against some headwind. So we're going to take our rate and we have to subtract W because we have to subtract the headwind. And then our flight home, we have the tailwind, so we're going to go faster. So we're going to add that. We're going to add W. So the flight to California took 4 hours, and the flight home took 3.5 hours. And the distance is the same because the distance is the same to California and then back home. So now we have two equations. The first equation we get from when we do rate times time equals distance for the flight to California. So we get 4 times P minus W equals 1900. Our second equation is when we do rate times time equals distance for the flight home. So we get 3.5 times P plus W equals 1900. So now that we have two equations, the first thing we want to do is we want to solve for one variable. So I'm going to take this first equation and I'm going to solve for P. So the first thing I want to do is distribute. So I get 4p minus 4w equals 1900. Then I'm going to add 4w to both sides. So I get 4p is equal to 4w plus 1900. Then I'm going to divide everything by 4, and I get P is equal to W plus 475. And now that I have P solved for, I'm going to plug P back into my second equation, but instead of writing P, I get to write W plus 475. So I'm going to write 3.5 times, but instead of writing P, I'm going to put W plus 475, and then the plus W equals 1900. So now distribute 3.5 times W, 3.5 times W, that's 7W, and then 3.5 times 475 is 1662.5 equals 1900. Now I can solve for W. So I'm going to subtract 1662.5, and then I'm going to divide by 7. And when I do that, I get 33.9 decimal. And we're going to go ahead and round to 34, right? Because 33.9 rounds to 34, which tells us that if W is 34, if I want to find out what my P is, I had to take my W, which is 34, and add 475. So P is 34 plus 475, which is 509. Which tells me that the rate of speed is 500 knots, but we have a wind speed that we're either going up against or we're going with, and that is 34 knots. So it's your turn. You're going to do 7.6, 2 through 6 evens. It's due in class with your notes.